Okay, let's see if we can close out this this review. So given this, I want to try and draw a sketch of the second derivative and a possible graph of the first derivative. So given that this is the first derivative, so the second derivative is going to be the slope of this function. Well, the slope of this part right here, this is a horizontal line. So the second derivative is going to be 0 from 0 to 2. On this section, this is a constant change. So we started off at the point 2, 1, and we went to the point 4, 0. So the second derivative on this interval here is going to be down 1 over 1, 2. So constant negative 1/2 from here to here, negative 1/2. And again, at this point, this is a horizontal line, so the slope of this part is constantly 0. So let's see what this means. This was the second derivative. This original graph was f prime of x, so these were the slopes. So what this is saying is that if I look at kind of a first derivative number line, 0, 2, 4, 6. These numbers from 0 to 2 are positive numbers. So my function is going to be positive in that interval. It's going to be going up. And I can tell that it's constantly 1 because this is a horizontal line. So it's going up with a slope of 1. It has no concavity, so it's a straight line. We talked about that in one of the ones, question 3. Or question 1 rather. So this is a horizontal line because it has no, this is a horizontal line here, so the function will have no concavity. It will be just a straight line. Then in this interval, these numbers are positive. So if those numbers are positive, they're positive because they're above the x-axis. We have this for a slope. These numbers here are negative, so my slope is negative. And in fact, it's constantly negative, negative 1. My second derivative number line, f double prime, 0, 2, 4, 6. From 0 to 2, I had no concavity, so we're a straight line. So no concavity means we have a straight line. From 2 to 4, from 2 to 4, I'm looking at this section here right now, negative, concave down. And from 4 to 6, no concavity again, so a straight line, but now my straight line is going to be pointed this way, and I know that from the fact that this and this section, so straight line with a slope of negative 1, straight line with a slope of positive 1. So no concavity, straight line, no concavity, straight line. In the middle, I'm concave down. Okay, so now let's try and draw this function. It could be anywhere vertically. I'm going to start it here because I know that if it has a slope of 1, that's going to be off the graph. That's okay. So if it has a slope of 1, it's going to go here to here. I should have given you guys more space to do that. Okay, so a slope of 1. And then it's concave down, but a positive slope. So something that is concave down with a positive slope looks like this. These connect right here. And then a negative slope. a slope of -1. So just this straight line there. So again, constant increase because this number was positive, concave down but increasing, so concave down because this was negative, increasing because these numbers were positive, and then straight line that's decreasing because the slope was constantly -1. I knew it was a straight line because it had no concavity. All right, so let's draw this second derivative. Going to have a horizontal tangent here and a horizontal tangent here. So the second derivative, the slope of these are positive slopes, 0, negative slopes, and then positive. Positive, negative, positive. Positive going towards 0, negative, positive. And this is the second derivative. So this was f prime of x. So now if I want to draw the function, let's draw our number line. So f prime of x. F prime of x, well, -1 and 3 are when this slope should be 0. These numbers here are all negative numbers. Negative numbers, or negative slopes, go down. Everywhere in this interval, these are positive numbers. So we're positive in this interval. And then over here, we're also positive. A number line for the second derivative. Let's call this like 0.25. So I'm looking at this point right here. So we'll call it 0.25. I'm just kind of coming up with something there where it's close to. And then 3. These numbers are positive. So if these numbers are positive, concave up. These numbers in this section are negative, concave down, and then positive again, so concave up. And let's just get a general picture of the graph. So negative slopes, positive slopes, positive slopes. And now concave up, so it's going to be collecting. It switches to concave down, and then it still has positive slopes, but it switches from concave down to concave up. So let's put that general picture on this graph over here. Where if we look, this and this is where my slope should change from negative to positive, so that's okay. This point right here is supposed to be where I change from concave down to from concave up rather to concave down, and then we have a change here from concave down to concave up. And this could be anywhere vertically. Okay, so for what values of x, if any, is the function not differentiable? The function is not differentiable when we look for 3 different things. The 3 things that we look for are jumps, sharp corners, and vertical tangents. So if we're along this graph, if we move along this graph, at this x value, we jump from this point to this point. So we don't know whether we should be drawing in this tangent or this tangent. So we have this function not differentiable at x equals 2. And our reason is because we have a jump, or we say the graph is discontinuous. Then let's follow along the graph. until we come to another point where we're not differentiable. And we get to this point right here. And it's a little tough to see, but if we zoom in, we can see that that's a sharp corner where we don't know if we're talking about this tangent line or that tangent line. So on the quiz it will definitely be a little bit more distinguishable, but because we have a sharp corner there, this is also not differentiable at x equals, this x value was 4. And then the reason was because of a sharp corner. Let's again follow the graph. So we're here now. Let's follow it. As we move along to this point, we have to go here. Well, if we drew in the tangent line at this point, the tangent line at this point would be vertical. So again, the graph is not differentiable at x equals 5 because of a vertical tangent. Alright, this is a little bit of a throwback from pre-calculus where we're told the equation for a circle that has a center at the origin and a radius of the square root of 19. Well, the square root of 19 is somewhere between 4 and 5. So if the square root of 19 is somewhere between 4 and 5, this circle centered at the origin is just going to have a radius somewhere between 4 and 5 that looks somewhat circular. So there's our circle. And we're asked to find the slope of the tangent line at these various points. So x value 0, y value 19. X value 0, y value square root of 19 is just going to be this point on the circle right here. 0, comma, the square root of 19. The tangent line at this point is going to be horizontal. So the slope of that tangent line will be 0. At the point square root of 19 comma 0, so the x value is the square root of 19, the y value is 0, that tangent line will be vertical, the slope of the tangent line undefined. And lastly, the point positive 2, negative square root of 15, and we're thinking of that tangent line. So if this is the point 2 comma negative square root of 15. I don't know the equation for I don't know the slope of that line, but what's fortunate is that since we know the coordinates of that green point and we know that this is the origin, if we drew in this peach line, because the green line is tangent to the circle, this would form a right angle, or the lines would be perpendicular. Perpendicular lines have opposite reciprocal slopes. So if we started at the origin and we went down the square root of 15 units and right 2 units, the slope of this line will be down the square root of 15 units, right 2 units. So the slope of the line that we're looking for will be the opposite reciprocal, or 2 over root 15. Okay guys, let me know if you have any questions. Hopefully that helped. I'll see you guys all tomorrow, and best of luck.